Hello guys, welcome back to my channel. Today we shall see how to join two Numpy arrays or how to split two Numpy arrays, and also we shall search and sort through Numpy arrays. So firstly let us start from joining. Joining is nothing but putting the content of two Numpy arrays together in a single Numpy array. We can do that using a concatenate function. In concatenate function, we may pass the arrays we want to concatenate and also an axis, and if no axis is specified, it takes the default axis to be 0. Let us see what the axis is and how to work with concatenate function. Firstly, let me import Numpy function as np. Now I have my first array to be arr is equals to np dot array. If you don't know how to create arrays, I'll throw the link in the description box. You can go through that video and see how to create arrays. Okay. Now I have my elements to be 1, 2, 3, 4. And also my second array to be array1 is equals to np dot array, and this time I have elements to be 5, 6, 7 and 8. Now I want to join these two arrays. I'll name that array to be new array is equals to, I'll use np, as concatenate is also a function within Numpy module. So np.concatenate arr and arr1. Firstly, let us see without specifying any axis, and then we shall go and see what axis is. Okay. Now I'll print my new array n underscore arr. I'll run my program, run numpy arrays. Sorry, it has returned some error. Yeah, only integer scalars can be converted to scalar index. So here do not forget to specify double parentheses, run numpy arrays. Yeah, this time it has returned the joint array 1, 2, 3, 4, the elements of our first array, 5, 6, 7, 8 are the elements of our second array. So in this way you can join two arrays. Here I want to specify my axis to be 1. Let us see what happens. According to my assumption, it returns an error. So let us see. Yeah, axis 1 is out of bound for array of dimension 1. You cannot have elements as 1, 5, 2, 6, 3, 7, 4, 8 for arrays of dimension 1. Okay. So now let us create a two-dimensional array here. Here I'll have this to be, and also I'll specify, yeah, this is my two-dimensional array for which my first column is of elements 1 and 2 and second column is of elements 3 and 4. Now I'll change my second array similarly. Yeah, it's done, and I'll run my numpy arrays. Yeah, this time it has returned 1, 2, the first column of our first array, and 5, 6, the first column of our second array, and also 3, 4 of first array and 7, 8 of second array. Now I'll just change this to 0 and see how it works. Yeah, it has joined all elements in a linear manner 1, 3, 5, 7 and single dimensional arrays. But I'm not able to do that with concatenate function. Here comes the use of stack function. Stacking means putting elements one over another, which we are going to do now. I'll use np.stack. I'll remove my second dimension here because I want to check single dimension array, right? Yeah, I'll change axis to 1. Stack function works just similar to concatenate function, whereas we can put elements over one over another. Okay, sorry, yeah, I'll run it again. Yeah, this time we have joined our elements using stack function, also with axis 1, whereas last time using concatenate function we can only use axis 0, right? And also you can stack along rows and columns. We have specific functions for that. Stack, I'll remove axis here. Stack and vstack are used to stack along rows and columns respectively. Stack is used to stack along rows. Yeah, it has returned 1, 2, 3, 4 and 5, 6, 7, 8 as in the form of concatenate function. Now vstack returns it has stacked along columns, right? Now also you can stack along height. What is height? What is stacking around height? Last time when we have specified axis is equals to 1, we have got 1, 5, 2, 6, 3, 7 and 4, 8, right? In the same way we can stack using dstack function. Here d is depth. Yeah. So in this way you can stack your Numpy arrays. Now let us see how to split our Numpy arrays. When we are able to stack or join our arrays, we must be able to split our arrays also, right? Now I'll remove this print statement. I'll just concatenate these two arrays. Now I want my single ARR and ARR1 differently after splitting my new array, which is concatenated. You can use array_split function to split a single array into number of arrays you want. It takes two parameters. Firstly, the array you want to split and the number of arrays you want to split the given array into. Firstly, I want my ARR2 is equals to, I know it's a bad name, but just for examples, let us take it, okay? I'll use array_split function. And I'll specify my array, new array, n_array, and I want it to divide it into two parts. According to my assumption, it must return my ARR and ARR1 because the both arrays contain similar number of elements, and when divided into two parts, they must be returned, right? Now I'll print my ARR2. I'll run it again. Yeah, it has returned two arrays 1, 2, 3, 4 and 5, 6, 7, 8. Now I'll remove this. Now I want my ARR3 is equals to, I want to specify these two arrays in two different arrays. ARR3 is equals to ARR2 of 0, which is index 0 of ARR2. Now ARR4 is equals to ARR2 of index 1. I'll print these two arrays again. Print arr3 and also print arr4. I'll run my program now. Yeah, it has returned our two virgin arrays which we have created at the start of our program. Okay, in this way you can split two arrays, and also here instead of 4 you can split your array into 4 parts. I mean instead of 2, okay? Yeah, it has returned 1, 2, 3 and 4. Here I'll change it to 3. Yeah, it has returned 1, 2, 7 and 8. Now, as we have head split, as we have head stack, we also have head split in splitting our arrays. Let us see how it works. I'll run my program now, run Numpy arrays. Yeah, it has did the same task, but now I use two-dimensional arrays here, okay? 1, 2, to just see the working of head split. Now I'll run my program. Sorry, it has written some syntax error. Yeah, closing parenthesis does not match open parenthesis. Yeah, here I have to use another square bracket. Run. Array split does not result in equal division. Yeah, I'll change this to 2. You must have the number of arrays to be in equal division. Yeah, it has returned. Here I'll change this to 1. Yeah, it has returned my arrays. Array 1, 3, 5, 7 and array 2 to be 2, 4, 6 and 8. Okay, in this way you can you can split around columns, rows as well as height. Okay, as we have head split, we have V split as well as D split. Okay, now let us see how we can search or sort through our arrays. We have a function in Numpy which is where to search through our array. I'll just remove all this. I'll have one-dimensional array for the basic simple example. Now I'll use where function to find. I'll have index is equals to np.where. Also, do not forget to use np, or if you are not using any alias function, use numpy totally to specify any numpy functions. Or if you don't want to specify any np or something, just try from numpy import style. And if you are not doing this, remember to use np or numpy when you are specifying numpy functions. Okay, where of arr is equals to 2. Now I'll print my index. According to my assumption, it must return 1. And let us see what it returns. Okay, run numpy arrays. Oh, sorry, here I haven't used any np, right? So I'll remove this. Yeah, it has returned array of 1 with data type in 64. It is nothing but an array containing all the index values where the value is equal to 2. Now I'll have another 2 value here. Now let us see what it returns. Yeah, I have previously said that it returns an array containing all the index values where the value is equal to 2. Here we have 2 at index 1 and at index 3, right? So it has returned an array containing 1 and 3. Now you can also specify certain conditions to search for an array. Now I want all the elements which are even. I want elements which are divisible by 2. That is, I want the index of the elements which are divisible by 2. I'll specify array modulus 2 is equals to 0. Array modulus 2. Now I'll run my program. According to our assumption, it must return 1, 3 and 4, right? Yeah, it has 1, 3 and 4, where 2, 2 and 4, which has indexes 1, 3 and 4 respectively, are divisible by 2, right? Here you can change it to 1, or you can have any different conditions for your arrays to be searched of, okay? Now we also have another method to call search sorted, where it performs a binary search in an array and returns the index where the specified value would be inserted to maintain the sorted order. Firstly, to understand better, let us see how it works. I'll use this time index is equals to search sorted. Also remember that I haven't used any numpy function. I have imported the total numpy function. So I'm not using any specific np or numpy here. And if you are not doing that, remember to use np or numpy, okay? Now I'll have my array and I want 5 to be inserted within my array. I want to check where the 5 would be inserted so that my sorted order would not be changed. Here I remove 2 here because it deviates from the sorted order, right? Run numpy array, he shall return 4. That is, we have 1 at index 0, 2 at index 2, 3 at index 1 at index 0, 2 at index 1, 3 at index 2 and 4 at index 3. And when 5 would be inserted at index 4, it would not deviate the sorted order. Now I'll have another element 6 here for better understanding. Run numpy arrays. Yeah, this time even it has returned 4, where the sorted order would not be changed. Now this counts from the left side. Now if I want to count from the right side, you can specify your side is equals to right. We have a parameter named side, which you can have. By default it takes left, but if you want from right, you can have it also. Yeah, this time also it has returned 4, right? It takes ascending or descending orders. Now we also have sort function in numpy arrays. I'll change all my elements in a different manner. I'll have 1, 12, 32, 4, 6. These are of different order, right? Not sorted clearly. But now I want them to be in a ascending order. I'll use sort function here and I'll specify my array. I'll run my program now. Here I'll change this to new array and underscore array. I'll run my program, run numpy arrays. Sorry, here I have forgot to change my print statement. New array. Yeah, it has returned all my elements in a sorted manner, right? You can also sort out arrays containing strings. I'll use firstly my colors as usual. I use always colors, right? Yellow, green and blue. Okay, I'll run my program. It sorts according to the alphabetical order. Yeah, blue, green and yellow. So in this way you can sort out arrays, you can search within arrays, you can split, join arrays. So that's all for today. I'll come with another new topic, and until then stay tuned, subscribe to my channel. Also, if you like this video, please like it, and if you have any doubts, reach me out in the comment section, and if you have any Python buddies, please share this video with them. Okay, thank you, bye bye.